Hi guys, so today we'll be talking about casting procedures and defects. So it is about how you form a restoration like a crown and what defects could arise in forming of this restoration. Okay, so talking about the casting procedure, I'll be talking about it from an examination point of view, so I won't be going into too much detail. Okay, I'll cover this in one lecture. This is a one shot lecture. So starting with the steps in casting, the first step you have is a tooth preparation. So imagine if you have a defective tooth in your mouth. Okay, so these are all the teeth in your oral cavity. I will shave down some of the ends of this tooth, okay, and I'll prepare it to receive a restoration, okay. So the tooth will look something like this now. So this is called tooth preparation, okay. If any of your family members have a crown or something installed and it falls off for some reason, you can see their teeth will look like this, okay. So this is called tooth preparation. Now the second step is impression. So you take an impression tray and you record an impression of the entire mouth and then you pour some gypsum on it and you obtain a cast. Okay. So that is called impression taking. The third step is dye preparation. So you got an impression of this mouth. Okay. You knock off these tooth adjacent to it. You remove these tooth. Okay. And then on this die, this is called die preparation, and then on this die, you go on step number 4, you fabricate a wax pattern. Okay, so you will take some inlay wax and you will form a crown on top of this die. You will give all the anatomical features to this crown, okay, and then you will fabricate this wax pattern. Now, what will happen to this wax pattern? What is this entire process? Okay, here I have this wax pattern. I have attached it to a sprue. A sprue is like it is like a channel, okay? It is a pipe kind of. What will happen is I will pour some gypsum in this ring-like structure. So this is a casting ring. You would have seen this. This is like a hollow cylinder. I will take some gypsum or a phosphate bonded investment material. I will pour it in here. Okay, I have this wax pattern attached to the sprue. Then I will heat it up and this wax pattern will burn out, okay? And what I will be left with is this empty mold, okay? So this will be the empty mold I'll be left with. And this screw will be there as always, okay? Then I will take some metal, okay? I will take some alloy, I will melt it and I will pour this metal through this screw into here and I will get this metallic restoration, this crown. So this is the entire process, the casting procedure, okay? So this is for you to understand. I explained up to step number 4. Now I'll be talking about the sprue former. Okay, so what is a sprue former and why do we use it? So sprue former, this is the sprue, right? It is made of wax, plastic, or metal. Okay, it has to be a certain thickness. It has to be in proportion with the wax pattern. Okay, it should be attached approximately 1 by 4 inches from the top of the ring. Okay, not more than that. So it has to be a certain height. What is the purpose of this sprue former? Okay, why do we need it? So it forms a mount for the wax pattern. So it allows, like, it acts like a stand for the wax pattern. It allows it to stand it in the casting ring. Okay. So it forms a mount for the wax pattern. It creates a channel for the elimination of wax during burnout. So when you heat this thing up for the wax to burn out, the wax will flow out through here. Okay, it will flow out through this channel. Now this will again allow the molten metal to enter the channel. Okay, so this is the third purpose, and then it compensates for alloy shrinkage during solidification. So what is that? uh, when the metal you have used, okay, the metal will obviously shrink because when it is in liquid form, it is due to thermal, you know, the thermal thing, right? So when it is in liquid form, it has a higher volume, and when it gets converted into solid, it shrinks. So the sprue will allow more metal to flow in here, and any shrinkage that occurred, the sprue will compensate for that by allowing more metal to get into the mold. Okay, so this is the purpose of the sprue. Now moving ahead, the next thing we are going to talk about is the casting ring liner. Okay, so what is the casting ring liner? Here I told you this is the casting ring, and this is the casting ring liner. What is a casting ring liner? It is a paper. Okay, you have this ring and it will surround the entire ring. Okay, I will put a paper surrounding the entire ring. Why will I use it? So it allows for mold expansion. When I have gypsum in here, it will allow the mold to expand. And why do I want my mold to expand? So that this void, this mold that has been formed, okay, this void that has been formed, I want it to get bigger because the metal, as it will solidify, it will shrink. The metal I have poured in, it will shrink. So my crown will get smaller than the wax pattern I prepared. So if this void itself expands, I will compensate for that casting shrinkage. Okay, so it helps with that. Then the uh, it acts as a thermal insulator as well. So that is important for the casting process. Okay, and it permits easy separation of the investment from the ring. Okay. Now, what are the types of casting ring liners that we use? So first is we have asbestos and non-asbestos ring liners. Okay, the asbestos one is not used anymore because it is carcinogenic. In the non-asbestos, we have three types. We have the fibrous ceramic aluminous silicate, we have cellulose paper, and we have ceramic cellulose combination. These are the three types of casting ring liners we use. Now the fourth step, that is the investing. So we talked about up to step number 4. Now the fifth step is investing. Okay, and we were talking about the sprue former and the casting ring liner. They can come in as a short note. Okay, now talking about investment, it is nothing. It is just pouring of the gypsum in your casting ring. So that is called investing. Okay, a wax elimination. So that is burning of the wax and forming of this mold. That is wax elimination. Okay, now casting. So step number 7, that is casting. What is casting? I have this empty mold over here. Okay, my wax got burnt out and I have this empty mold with a screw attached over here. Now I want molten metal to flow into here, flow in this mold and fill this mold. Okay, how will I do it? Need casting machines that will pressurize the molten metal into the mold. So I have two types of casting machines. I have centrifugal force type and air pressure type. Okay. The centrifugal force type will use, as the name says, centrifugal force to pressurize the metal into the mold, and air pressure type will use air to pressurize the metal into the mold. Centrifugal force type is the one that is preferred because it can be used for both large and small castings. And air pressure type, it uses some carbon dioxide or nitrogen gas to pressurize the molten metal into the mold. Okay. Now, fusion of the metal alloy. So, in order to pressurize the metal, you have to also melt the metal, right? So, how do you melt the metal? So, there are two ways, mainly by blowtorch, or you can use an electrical induction. We use a blowtorch mainly. This is a blowtorch and it has 4 zones, okay? So, it has mixing zone, combustion zone, reducing zone, and oxidizing zone. So, talking about the mixing zone, air and gases are mixed here. It has no heat and it is dark in color. Okay. Then the second, combustion zone. It is green and color. It is a zone of partial combustion, and it is an oxidizing in nature. Right. Then the third zone, reducing zone, the most important zone. It is blue in color. It is hottest, and here fusion of casting alloy takes place. So this is the zone where your metal will melt. This is where you need to keep your metal, right? And then the oxidizing zone, it is the outermost zone, and final combustion of all the gases takes place in here, not of our use. But you should remember this diagram on all these zones. This is very important. Okay, now after this, you have pressurized the metal into your mold and you know about the blowtorch. Now, talking about quenching, it is the next step. So, it is the step number 8. Okay, step number 8. So, after you have pressurized your metal, it is immersed into a container of water. Okay, so to cool it down, okay, and keep it in a softened condition for a longer time. Right. Now, recovery of casting after it has cooled down and everything has happened, you take it out of the investment, you take your crown or the restoration out of the investment, then you do sandblasting. Sandblasting is just cleaning of the surface of the metal, okay? Then, so step number 8, 9, and 10. Now, step number 11 is pickling. So you put the casting in 50% hydrochloric acid or sulfuric acid. It is heated. It just clears off all the oxides from the casting surface. Okay, so if you have any remaining oxides on the casting surface, it clears that off. And then polishing. So polishing is just cleaning of the surface and removing any abnormalities. Okay, not abnormalities, but mainly anything that sticks out of the casting. So that is polishing. Now coming to the casting defects. That is the second part of this lecture. So there are mainly four types of defects. Okay, first is distortion, second is surface roughness, third is porosity, the most important one, and fourth is incomplete casting. So talking about distortion first, I told you we prepare a wax pattern. Imagine if something happened to this wax pattern, okay, if it got like mm, a little pressed in here, okay, so that is distortion. Some distortion can happen when the investment hardens due to hygroscopic expansion and the thermal expansion. So imagine your investment is getting hard and it presses upon the wax pattern. That can cause distortion. Okay. Some distortion can happen during manipulation. So I am forming the wax pattern and I accidentally put a cut over here. So that can cause the distortion. Okay. So how can you minimize distortion? By manipulation of wax at high temperature, investing pattern within 1 hour after finishing, and if storage is necessary you store it in refrigerator. Okay, so this is all about distortion. Now there is something called fins is a part of surface roughness. Okay, so that is the second type of defects we are talking about, but I'll just talk about it in here because it can come in as a short note as well. So this is fin. This is just an extension of then an abnormal extension of the restoration you formed. Okay, so it is just an extension. How can it be formed? Due to flow of molten metal into cracked investment. So I had this investment over here. Imagine a crack happened over here, and the metal flew inside this crack and it formed a fin. Okay, so this is what a fin is. How can you avoid having it? So you have to use proper water to powder ratio. Okay, avoid rapid rise of temperature during wax burnout that can cause cracks in your investment, and avoid high casting forces. Okay, so that can also cause fins in your casting. Now, surface roughness and nodules. So the second type of distortion we were talking about, we talked about distortion, and the second type of defect we were talking about is the surface roughness. So it is any minor roughness on your casting, right? It can be air bubbles on the wax pattern. It can be fins. It can be turbulence and flow of molten alloy that can cause some roughness. Okay, coarse casting surface, or disintegration of mold walls. This can all cause surface roughness. Okay, how do you avoid it? So you have to properly mix the investment, vibration of the mix, application of wetting agent. So that is to avoid air bubbles. Now, if you have fins, you have to heat the ring gradually to 700 degrees for 1 hour. You have to avoid rapid heating of the fins. Okay. So to avoid the flow to avoid the turbulence and flow of molten alloy, you have to attach the screw at 45 degrees angle to the wax pattern. Okay, so this will avoid any turbulence and flow of the molten alloy. Now talking about how to avoid coarse casting surface roughness and disintegration of mold walls. So you have to use the proper water to powder ratio of the investment material. Okay, you have to take in consideration the size of the investment particles. So you should have fine particles of gypsum or phosphate bonded, whatever you are using. So you should have fine particles of your investment material. Okay. Now, prolonged heating of investment should be avoided, or overheating of the alloy should also be avoided because that will cause disintegration of your investment material or the mold walls. Okay. Now, moving ahead, talking about the third type of defect, that is porosity. So what is porosity? Porosity are tiny voids, okay, tiny holes. You can have them inside the surface or on the surface, okay. So majorly there are three types of porosities based on the reason of why they are made. Okay, so first is the solidification shrinkage porosity. This itself is a big topic, so not big, but it has its own classes. So I'll talk about this last. Second is the air inclusion porosity, and third is the back pressure porosity. So, what is air inclusion porosity? You have this mold, okay? You have this empty mold, and you are filling in the metal. What happens is the metal, when it gets solidified, so this is your metal, when it is getting solidified, metals like copper or silver, they release some gases, okay? So they release some gases when they are getting solidified. This release of gases, it causes pinhole-like porosities, or if they are inside the metal casting, they are called subsurface porosities, okay? So they are caused due to release of gases while solidification of the metal or absorption of gases during the casting and later on release of the gases. This will cause gas inclusion porosity. Okay, so this is gas inclusion. Now the third type of porosity, it is back pressure porosity. Why is that caused? So I have this mold. Okay, I have this mold, and I have before I filled in the metal, I have air inside this mold. Okay, so I had air. Now, if the investment material surrounding my mold, here I have the ring, the casting ring, and the investment material. If this is all too thick, okay, if this is too thick, it won't allow the gas in here to escape. I need this gas to escape before I fill in my metal in this mold, okay? So if this is too thick, my gas won't escape. And what will happen if I'm filling in the metal? Some of the gas, it will stay trapped there, okay? It will stay trapped there in the thinner portions. Over here, I might have some gas remaining. Over here, I might have some gas remaining. What that will cause, my casting will come out to be round edged. So here you can see I will have incomplete casting. My casting won't be complete. It should come out like this, right? But this portion, because I had gas filled in here, it will come out with rounded borders, and it is because of the pressure of the gas. So what I need to do to avoid this? I need to use adequate casting force, okay? I need to use investment of adequate porosity, so it should have enough holes, my investment material, to let the gas out, okay? Placing the pattern not more than 6 to 8 millimeters away from the end of the ring. So the distance between my wax pattern and my casting ring should be 6 to 8 millimeters, okay? And providing vents in large casting to allow the escape of gas. Okay, so this is back pressure type of porosity. Now the first type of porosity we were going to talk about was the solidification shrinkage porosity. What do you mean by solidification shrinkage? Okay, so if I am putting the metal in and it solidifies, when it will get converted from liquid to solid state, it will obviously shrink. So if this was my liquid stage, and when it is in solid stage, it will come to this size. Okay, this will create a void. So this area, what you have over here, this will create a void. And this gives rise to solidification shrinkage porosity. So it is of three types: microporosity, localized shrinkage, and suckback porosity. So we'll talk about this. What is microporosity? Okay, so microporosities are small irregular voids formed throughout the casting. Okay, due to rapid solidification when the casting temperature is too low. So if my mold is getting filled in, I have this mold and it is getting filled in, and the casting temperature is very low, right? So as the metal is coming in, it is getting solidified. And it is getting solidified. So imagine this was the volume when it was a liquid. Now, but when it came to a solid, it's got shrunk. So from various places. So maybe there was a little hole created over here. Okay, little hole created over here, and there will be tiny holes everywhere because it is getting pulled apart, because it is getting shrink, so it is getting pulled apart the when it is getting converted into a solid. So this will create tiny holes all over the place, and that will be microporosity. Okay. Now the second type of porosity is the hotspot or suckback porosity. Why is that caused? Okay. So I have a sprue attached over here. Okay, if I move to the next page, okay. So this is the hotspot or sorry, this is the hotspot or suckback porosity. So it is opposite to the sprue. And why is that? So I have this mold, right? And I have a sprue attached over here. Now imagine this in 3D, okay? So this place around or opposite to the sprue, it will get very hot because there is molten metal coming in rapidly throughout. So as the metal is coming in, this place will get very hot, right? And as imagine this got completely filled in with the metal, right? All of this portion got solidified first. Everything other than this area got solidified first, but this area is still liquid, and this will get solidified last. Since this will get solidified last, and I have already filled in the area with metal, now there will be a small void created over here because when it was a liquid, it had a larger volume, but now since it is a solid, it got shrunken, and the liquid was pushed away from this area because this was the hot area. So all the liquid it got solidified and the volume reduced and it created a void in here. So this is called hot spot or suckback porosity. Okay, the molten alloy raises the temperature of the mold opposite to the sprue and the alloy solidifies last at the spot and the liquid is sucked out of the spot. Okay, so to avoid this, the temperature of the liquid should not be very high and thickness of the sprue should also be reduced. So if it is thin, the spot will be very thin as well and it will be evenly distributed. So this porosity, the chances of this porosity will be reduced. Okay. Now the third type of solidification shrinkage porosity is the shrink spot or localized shrinkage porosity. What is this? So it occurs when the sprue is too thin. Okay, and it occurs near to the sprue casting junction. What happens in this porosity is that you have a very thin sprue, okay, and metal is coming in very slowly and slowly. Okay, so it is coming in, and since it is getting filled in here, this because it will take a lot of time to fill in the mold, the surface will start solidifying. Okay, so imagine this area, it is on the surface and it is getting solidified and the inner core is still hot because the sprue was very thin and the metal was coming in very slow, right? So now the surface has solidified, so this area is also solidified because the sprue was barely, it was like a pinpoint, it was very thin. So this area also got solidified. Now, since the metal inside at the surface inside in the core, it is still very hot. Okay, now, when this will solidify, again the liquid will be sucked out of the some places because it will shrink and it will create tiny voids inside the casting. So that is shrinkage or shrink spot or localized shrinkage porosity. Right, to avoid this, the sprue should be thicker than the pattern to be casted. Okay, flaring of the sprue should be used. So flaring means like kind of spreading it out if the sprue is thin, right? Attaching the sprue at the thickest portion of the wax pattern. Okay, so you should do all this, and you can also place a reservoir to avoid any shrink. So reservoir is just like a small tanker which will contain extra metal alloy to fill in any voids that are present. Okay, so you can use a reservoir as well to avoid this shrinkage. So porosity is the most important topic in this entire lecture, all of these porosities. Now coming to the last defect, that is incomplete casting. So what happens in incomplete casting is your restoration will come out incomplete. When it is normal, it has pointed edges and finished edges, okay? But when it is incomplete, it will have round margins. So it will be like this, okay? So this will be your casting. It will look like this. What are the reasons? You could have insufficient alloy. Okay, your alloy was not able to enter the thin parts of the mold, so like these parts. When the mold is not heated to casting temperature, so maybe it started solidifying first. Okay, premature solidification of the alloy. Sprues blocked. Okay, so that will again lead to the insufficient alloy used. Back pressure due to gas mold. So back pressure porosity, I told you it causes incomplete casting. This one, it causes incomplete casting, right? Low casting pressure, so again the alloy won't flow into the thinner portions and alloy not sufficiently molten or fluid. So it will not go into the thin portions again. What will it look like? So it will look too bright, shiny and casting with short rounded margins. Okay, so this will look like this. And casting with gas blowholes or suckback casting. So this can cause if there is any residue remaining in the pattern chamber or surrounding investment, it gives off large volume of gas. Okay, so if there is any like tiny portion of wax remaining in here, like it will cause a large amount of gas to come out, and this will prevent the metals flowing into this area, and it will cause incomplete casting. Okay, so this is one of the reasons, right? This is it about casting defects and casting defects and casting procedure. This lecture should be enough for the university exams to pass. Okay, I have tried to cover it in one shot, so I hope you like it. Thank you.